Hello, everyone. Thank you for joining. Welcome to the Building a Data Science Team series. While maybe a few more people trickle in, I would like to quickly introduce ELU and the people on the call today. So thank you again for joining. My name is Lara. I am the community manager at European Leadership University. And European Leadership University is a next generation university. We are founded just a few years ago. With the mission to bridge the skills gap in the Netherlands and the EU at large. So we are focusing on the skills development of our students and our learners. But at the same time, we also want to build a community of data scientists and also tech recruiters in the Netherlands and educate the market. We do see that there is a need to understand this kind of huge and very trendy field, but sometimes a bit maybe misunderstood field of data science. And it is for this reason that we're offering this webinar series. This is the second webinar in our Building a Data Science Team series. And today I'm very excited to be joined by Longhow Larn. Thank you so much for joining and agreeing to speak today and sharing your expertise.
Yes, thank you for inviting me.
Thank you. So also this series is built on a Coursera course. If you are interested in joining our full webinars, please reach out to myself or to my colleague Christella. Christella is our relations lead. She will be leading the the conversation with Longhow today. So without further ado, I would like to pass it on to Christella. Now, if you have any questions, we will make some time for your questions as well. So you can drop them either in the chat or in the Q&A boxes down below in the Zoom controls. Thank you again for joining, and Christella, the floor is yours.
Yes, thank you, Lara, and welcome again, everyone. Very excited for this interview. As Lara said, I'm the relationship lead at ELU, and today I'll be interviewing Longhow. Longhow is a very experienced data scientist. He has been working for many years in the field, I think even before it was called data science. For example, Shell, ING, RTL, and now is working as a freelancer at Adidas.
Yes.
Perhaps you can give a little bit more of an introduction in a bit, Longhow. We'll be talking today about the data science field, what is happening, what are the skills that you need today as a data scientist, and how is the field, how has it evolved, and what are the expectations for the future? I think you'll have a lot to say about it, but maybe you can tell us a little bit more about yourself and where you came from.
Yes, thank you, Christella. My name is Longhow, and a long time ago I studied mathematics and statistics. Well, in fact, it was statistics as a major in the mathematics department. That was back in '95, so a long time ago. And basically, after my study, I worked in different companies, but I started, my first job title officially was applied statistician. And that's a long time ago, but if I look back at that period, I still do similar things that I did 25 years ago. So in that sense, and we'll talk about more, I guess, not a lot has changed. But yeah, so over the years, I worked at ABN AMRO Bank, at ING, and also at RTL. So my hobbies are also doing data science, hobby projects. Maybe I can tell a little bit about it later on. As a data scientist, you have to keep your skill set up to date, and not always at your work you can do that, but then sometimes you have to invest time to do hobby projects. So that costs a lot of time. So and yeah, for the rest, I'm married. I have 2 kids, a son and a daughter, 10 and 8. What else can I say? Live in the lovely city of Amsterdam. Yeah, so that in a nutshell about
yeah, that's great. Thanks. We'll definitely get back to some of the things that you're mentioning. I wanted to start by talking shortly about definitions, about how you name things, because we hear so many manners to describe this subject, right? Do you call it data science? What do you call data science? What do you call data engineering? What is BI and what is AI? Can you, in short, give us your view on this matter?
Yes, I mean, it's a huge field, and if you only consider data science, then you have already some subfields. But to make it even broader, the things you mentioned, data engineering, BI, is even broader. To me, in a nutshell, data science, and it's a very general, a very short description, is two things. Getting information out of data that can be used by the business. But okay, that is too concise, because working with Excel and making a graph, you can also earn a lot of money and get a lot of insight out of that. But that's not really data science. So my emphasis is then getting insight out of data using more advanced analytics and analytical techniques. Now, and then of course you can argue, what is that exactly? Some people say, yeah, doing a regression analysis or a cluster analysis. So these are concrete examples. And to me, that would also qualify as being a data scientist, doing data science. So yeah, that's one thing. And the other thing is traditional BI or data engineering, where you're not using advanced algorithms per se, right? So in traditional business intelligence, you are interested in reporting a number and as precise as possible, how many customers did leave your company. That is not data science, that is business intelligence. But if you're going to predict that number by using more advanced techniques, yeah, then you come into the data science space. And the other thing, data engineering, it takes a lot of time and it takes a lot of effort to get to that number. How many people have left your company? How many customers have left your company? And to get that data accurately and consistently every week or every day, that is, in my opinion, data engineering. Yeah, so this is very short.
Yeah, there's a lot to say about it, obviously.
There's lots more to say, lots more definition. If you ask other people, they will come with different or slightly different opinions.
Do you still call yourself a data scientist nowadays?
Yeah, well, the data scientist, the term itself has become very popular a few years ago, because then it was super cool and super hot. The data scientist who could do everything. Nowadays, if you call yourself a data scientist, it's more like, well, it's not that positive anymore. It's a data scientist with his ugly script and notebook and inconsistent code. So now you get more specializations. So 5 to 6 years ago, you had the data scientist who could do everything.
Right.
Well, that's not true anymore, because that is like the jack of all trades, master of nothing. So now you have more specializations, like machine learning engineer, the data engineer, but also the applied statistician and more the business analyst part of data science are coming back. So it depends a little bit on what you like. And obviously nobody can know everything at a high level. So you have to specialize. So I cannot do software engineering at a high level, and I don't want to. So my preference is to talk with the business, understand their issues, and translate that to a model, and creating the first models to see if it has value at all. That part of the data science is I always like to start things, and I of course I want to finish things, but then if you have to maintain your model, your solution, then it becomes a little more boring.
And would you say that those first steps are the most, is that the most important skill for you in your daily job?
Yes, because unfortunately I've seen a lot of data science projects, they just started without any link to the business. Now that is a part that sometimes is skipped. but it's very important. You have to align with the business, understand what their problem is, and see if data science is a solution at all. I mean, sometimes you can hear people with an issue in the business, and then you say, well, this is not a data science solution. And so I'm not going to solve your problem with data science. You have to have some courage to say that. But once you can identify nice business issues that can be solved with data science, okay, yeah, then you can start become more technical. And even then, you start with the more simple approaches, baseline approaches, simple models, just to get an idea, just to see if you can work, if this can work at all. You can always iterate into more difficult things.
Yeah, so you start with some testing to see if it's actually going to add any value.
Yes, and the mistakes I've often seen is that people start, because it has to be data science, it has to be machine learning, often start very complex.
Right.
And yeah, that's cool, of course, but that should not be your first iteration.
Yeah. Okay. And so how about the tooling? Because obviously in the, 20 years that you've been doing this, a lot of tools and programs have come and go. What do you think in 2020 are the most important tools for a data scientist?
At the moment, I'm using Python most of the time, a little bit of data EQ, and maybe we can talk a little bit more on that. A more graphical user interface program, and a little bit of H2O. But as you said, in my 25 years of working with data, I've used different tools, and maybe nice to show a slide. Let me share a screen. Can you see the slide?
Yes, I can see it.
Okay, so basically, you need to learn your whole life. That's an open door. That's trivial. But the tools I started with 25 years ago and use it quite a lot were SPSS and SAS. They are still around. You can still do nice things with it. But when open source came around, these tools got a little bit more to the background. And yeah, 15 years ago, when you knew SAS, you were king of the hill, right? So you could get a job everywhere. You just say, I'm an expert in SAS, and they would hire you immediately. Those days are gone, but the models didn't really change, but the tooling changed. So then, let's say 8-9 years ago, when the whole big data and data science became popular, I had to use, or I used R a lot. And I also used R because I knew it from the university, because R is not really that new, it's quite old in fact. But then the last few years, even R became less and less popular. And now in machine learning and in data science, Python is the obvious choice. So if everybody says to me, what tool should I learn first? And you're from a more program or coding environment, you like coding, and you're not afraid of writing a piece of script, just go for Python. And of course, it's not only Python, there's a lot of packages in Python as well. But with Python, I mean the Python ecosystem. And then you see here two logos of tools that I sometimes also use. And this little bird here is Data EQ, spelled with a K, and H2O. Now, Python has these nice things. You can do everything with Python, but the thing is you need to learn a language. Now, for some people, that may be a little bit too much. Then there are tools like Data EQ, where you have a graphical user interface, a flow interface where you can do data science. Now, that is not new because that was already in SAS and SPSS already. People who are above 40 or 45, they know SPSS Clementine or SAS Enterprise Miner. These tools were around 20 years ago, where you could easily click on some buttons to generate a data science model. Now, with these tools, over the years, I also had different titles. As you see here, I started as an applied statistician. Then a long time, I called myself a data miner, and now data scientist. But maybe I should call myself machine learning engineer or AI specialist. I don't know yet. It's just a name, so I stick with data science for now.
Right.
So these are the different tools, for me at least. I mean, in my specific data science field. I mean, there are many more tools, of course. Like we cannot cover them all, but these are the main tools to use, to just go to.
And what do you think? Because we talked about it a little bit before we started the interview about these drag and drop tools. So these are tools that are supposedly making data science super accessible for people who might not have any coding skills, for example. What do you think that means for the field?
I think there's a new stream of people coming up who know the business, who have some expertise in that, and who know what the data looks like, because they're working with their own data for a long time, but they don't necessarily have the hard coding skills that you need to create a machine learning model in Python or R. And these are two camps almost against each other. So the people who believe in machine learning that should be done with software engineering skills. And you also have people who say, I don't have the right software engineering skills, but that doesn't matter. I can create models with a tool. Now, some people don't like that. I'm very pragmatic. I've done both. I've created models with both sort of tools, right? Creating them in Python and maintaining them with good software engineering skills. But also with Data EQ or SAS or SPSS in the past. And that is handy really when it depends on the environment, the department, the company where you're working, of course. And suppose you're starting a new project, you don't have a lot of real data scientists that can code a lot, but you still want to show, or well, to see if a predictive model, for example, can have some value. Now then tools like Data IQ can really speed up that process.
So you don't really see it as a threat, you see it as an...
No, I don't see it as a threat. No, because when I started as a freelancer, but also at other companies, I want to quickly show results. I don't want to spend 6 months coding in Python to come up with something, or even if you're an expert Python programmer, maybe you can do it 3 months. But with these tools, it will help your productivity, not only in creating the model, but also in exploring the data and quickly create visualizations. Now, then of course, you can much more quickly show something and have a prototype model already. And then you can always iterate on it. And these tools are not always, I mean, most of the data science problems at companies, they're not that difficult that you need per se to write a lot of code. So most of the issues is predictive modeling. Predict if a customer is going to buy or not buy your product, or predict if the customer will cancel his subscription or not. These are fairly, between brackets, simple use cases to create a predictive model, and a lot of steps are already well known. You have to extract data, join them, create a few good features. So these can be already pre-processed in those tools. But the main important thing is that you know the business perspective, what is in the data, what will work and what doesn't work. And then you need to iterate with the business. And then it doesn't matter if you're using Python or a tool, but you need that knowledge. And then a tool like Data EQ will help you much more quickly to do that.
All right. Yeah, it's interesting, and actually it aligns. We're getting a question from the audience right now, and I think you've answered it a little bit already. It says, I will be recruiting a data scientist for my company. Is it more important to get a great Python developer or someone with good domain knowledge but weaker coding skills?
Yeah, that is exactly depending on what kind of growth of your company or department data science do you expect. For now, if you quickly want to start things, create proof of concept models, then I would go for the person with more business domain knowledge, but still have an understanding, of course, what data science is. I mean, a fool with a tool is still a fool, right? Somebody who can only click on some buttons, that is not data science. On the other hand, if you have a 20-year expert programmer, software engineer, that is not a good data scientist necessarily, right? So I would just go for the data scientist with good business domain knowledge and understanding of predictive modeling, machine learning, instead of having, an expert Python programmer.
Greatest coder, yeah.
Because, well, it's more likely that you will find somebody like that than an expert 10-year, 20-year programmer, and you can already get started. And when you need somebody with that specific skills, maybe later on because you have more difficult projects or different people, then you can always look for that. But you have to start somewhere. And you also start with a team. You don't hire one person. A data science project is never one person, one army show, right? So you need to have somebody from the business. You need to have data engineering.
Yeah, that's true. And in line with this, because I can imagine that there will be recruiters watching who have to recruit data scientists, but it's very hard for them to determine whether someone has the right skills. They can test the soft skills, but I was wondering, how were you in your hires mostly tested on your hard skills? Or weren't you at all?
Yes. When I was helping out companies in hiring and did a lot of interviews with data scientists, I not only tested hard skills. I as you said, I tested soft skills, like can you explain certain complex things easily to people, to the business? Do you have an understanding of the business? And of course, the hard skills that you mentioned. And yeah, with the hard skills, I would just ask some. Well, there you can have hard skills on statistics, mathematics, and coding or computer science knowledge. So I had a list of a few questions, just pick out randomly. Do you know this package in Python? And just go a little bit.
So you were actually helping those companies because they, with their hiring.
Well, helping in the sense that I was involved in a lot of interviews and helped the manager to decide who to choose, who to pick.
Because when you're a recruiter, it might be very hard when you're not a data scientist yourself.
Yeah, but of course, if you are a recruiter and you don't have a data science background, you still have to choose the right people for the company. And sometimes that can go horribly wrong. I mean, I was at a company, I don't mention the name, but we got a lot of CVs from our recruiting agencies and we said, what the heck is this? 9 out of 10, maybe 99 out of 100 could be, we could throw away. But yeah, just, I mean, if you ask a few technical questions in statistics, do you know the central limit theory? Do you know what a random forest is? You can, with a few of those questions, you can already select, the people who claim to be a data scientist and who are not.
Right.
There should be questions. Of course, then if you're a recruiter and you ask, do you know what a random forest is? And you need to know that the person who answered, then you have to make sense out of that, of course.
Yeah, that sounds good. I just wanted to say in the meantime, thanks to the person who added the question. And if anyone in the audience has another one, feel free to add. I was wondering, because the course that this webinar is a part of is about building data science teams. So who do you need for your team, but also about managing it. And you have been managed by many different people in the field, I think. Can you tell me what, for you as a professional, makes a good data science manager?
Yeah, I mean, the data science manager does not have one style for all the persons in all the people in his team, right? You just have a mixed team for people who are junior, medium, and senior. So as a manager already, you should acknowledge that somebody needs hand-holding, juniors, but the more senior guys, they should be left more alone and also managed differently. That is in general true, not only for data science, of course. But when it comes to managing a data science team, in my opinion, the good manager will also help you go to the business and sell or attract new projects because of his position where he can have more leverage than you as a data scientist within the team. Now, and there, sometimes things can also go horribly wrong. Seen a lot of managers who oversell and underdeliver, promise quite a lot. And that's where I guess then you should go together if you're in a company as a manager and as a senior data scientist or a lead data scientist, that you, because often a manager is not the technical person, not necessarily. So he might risk overselling the solution, while a good data scientist should see that and yeah, have bring in some balance into this.
Yeah, to do the right expectation management with the business,
with the stakeholders, with the business. Yes.
Yeah, right. That makes sense. So would you say that that is one of the greatest pitfalls in data science managing?
Yes, because a lot of data science teams, especially a few years ago, they just popped out of nowhere. A lot of companies wanted to do data science. So a lot of data science teams were set up, and of course, each with their own manager. And then, of course, okay, what are you going to do then as a data science team? And then a lot of managers were selling, well, let's say it just bluntly,
Right.
blah, blah. Did a lot of projects where people in the business were not waiting for or had no clue what they were doing. And then unfortunately, at a lot of companies, a lot of those data science teams were dismantled or just canceled. I've seen that happen a lot. So yeah, that is just one aspect, of course, of a data science manager who should manage expectations towards a business, the stakeholders. But obviously, yeah, you should have some feeling with data science as a data science manager. That sounds trivial, but unfortunately, I've witnessed a lot of managers who are managing me who had no feeling or no link with the field, with the data science field. Yeah, I mean, it can still go okay, but often it did not. So.
Yeah, it's a complex field, of course.
A complex field.
Well,
You don't
yeah.
have to know all the things, but at least you have to get some feeling for it.
Yeah. Yeah. All right. We got an interesting question from the audience, which I'll get to in a minute. So hold tight. But one thing that I wanted to ask you is, so the field is developing very fast, obviously. How do you keep up?
Yes, that's a good question. In my introduction, I already told you I do sometimes hobby projects.
Yeah.
And that's the way to keep up a little bit. Because in your normal project at the company, you do the project that you need to do. And often a tool is chosen and a certain methodology. So to learn something new, it's hard because then you have to be lucky that your manager will allow you to do new things. So to keep up with the new tools and new methodologies, I take an open data set from internet somewhere, an open data set or a scraped a website. And then I apply techniques that I see in blog posts that are considered to be new or relatively new. Yeah, and I just do it and see where I hit the boundary and read on the technique. So it costs a lot of time, and especially if you have a family with children, you also have to spend time on that. So yeah, that's one way for me to keep up. And I follow Twitter and LinkedIn with specific hashtags like machine learning, data science, and follow other people just to see what they are doing. Because there are many people who do this hobby projects or interesting projects. So if you follow them and see what they're doing, you also learn or keep up.
And it's a community that shares knowledge a lot, right? That's very eager to share their experiences. Yeah, that's one of the great things about it, I think. All right, thank you. So we have a good question from the audience. If there's any more, please add them now before we end the session. It's actually one that I had myself, what are the skills for the future, and what is the next step for the data field in your opinion? Good question.
Yeah, I mean, that's always hard to predict. If I look at all the predictions people made about how data science is in 10 years or 5 years, then most of them are wrong. To me, because I'm so long in this field, I'm a little bit skeptical. So let me explain. Then 25 years ago, people and companies were saying, yeah, data mining, that will be the new thing. And you have to learn all these new techniques and tools. Because if you don't do it, you will fall behind and you will go bankrupt as a company. Now that never happened. So a lot of companies went bankrupt, but not because they were doing too little data science or data mining back in those days. So to me, for companies, I mean, this is different from a university or at research level, of course, but just for, let's say, normal companies like where I'm working, Adidas or Shell or ING, whatever, their main business is not to do data science, it's to sell shoes, right? You can help them, of course. But so in my experience, often learning the most new advanced technique is only of a slight incremental value to the business. So 25 years ago, I was doing linear regression to predict which customer would relocate, move for the ABN AMRO Bank. Simple linear regression. And I did that simple regression again not long ago for ING. So, and it still worked 20 years later. So in that sense, you don't have to learn new techniques in new advanced models. But of course you want to progress, and of course you want to learn new things, and luckily there are. So compared to 10 years ago, it's much more easier to do computer vision and natural language processing. And there you see a lot of techniques that can be applied. So yeah, I would say that new things, I think a lot of companies will start using their unstructured data, documents, emails, texts, and analyze that. And with that, you have a lot of new techniques in the natural language processing field. So I expect more analysis, more businesses, more companies who would do projects in that field.
Okay, yeah. And one more question we got from the audience. Speaking of businesses that invest, Palma is asking, what is in your opinion one of the industries that will benefit by data science and machine learning, and in which you perhaps have not seen enough investments yet?
I think,
very interesting.
And it's also my hope, and it's also because I like also working in new industries, that the whole industry of lawyers, in my understanding, is a very conservative industry, and you have big law firms who would hire lovely people to look for a case within a large huge documents collection, just really literally physically. Now, of course, as I said, with natural language processing, with text mining, you can do much more. But I haven't seen that many success stories in that industry. So I hope, I believe that in that industry, for example, data science techniques will be applied more because it's just more efficient to do it. And they have a lot of documents, a lot of data waiting to be analyzed.
Well, why do you think it hasn't happened yet? Is it because it's a bit of a traditional or conservative?
I think so. I mean, a lot of big law firms, they're just doing the way they do things for 10, 15 years, and doing things differently, completely differently maybe, is just not only at law firms, but anywhere. Also at the companies where I work for, you have marketing departments who just are not willing to embrace data science because you have strong marketers who say, I don't need data science, I don't need your selection model, I can select my customers myself, right? So, yeah, so, and other industries, I mean, it's not one industry that you can pick out. Maybe at certain companies, certain departments have not used data science enough. So even at a big bank, at ABN AMRO Bank, for example, not all departments are using data science at the high level. So there's also a lot of improvement, a lot of room to improve at traditional sectors.
Still a lot of work to do for you and your colleagues. Yeah, which is good news, I would say. All right. I think we're about to come to the end of this webinar. I don't see any more questions at this point from the audience. I would like to ask my colleague Lara if she has anything she would like to add or ask.
I don't have any further questions, but I think it was very exciting. And Longhow, thank you so much for sharing all your thoughts. I think also the audience asked some great questions. So thanks to everyone joining as well.
Okay, thanks.
Thank you for being with us, Longhow. And anything you want to add?
No, I think we touched nice topics, and yeah, half an hour goes very fast. So
yeah,
there's much more we can talk about. But yeah, thanks for having me on this webinar series.
Thank you. And if people have any more questions, they can add them in the Slack group that we have for this course, and you can answer them there. And I can highly recommend following Longhow on LinkedIn because he writes nice blogs on these subjects as well.
Yes, thanks.
All right. Thank you very much, everyone. Thanks for joining, and hope to see you next week.
Okay, thanks. Bye-bye.
Thank you.
Bye.
Thank you, Christella.